Here we'll introduce you to a few different types of triangles, which are polygons that have exactly 3 sides. Take a look at these polygons down here. Which of these are triangles? Right, these 3 polygons are triangles because they each have exactly 3 sides. Let's take a closer look at this triangle over here. This is an example of an equilateral triangle, meaning all 3 of its sides have the same length. Let's make sure that's true for this triangle. So yeah, as you can see, all 3 sides have the same length, meaning this triangle really is equilateral. Take a look at these other triangles down here. Which of these triangles are also equilateral? Nicely done! These 2 triangles are equilateral. Next, let's look at this triangle over here. This is an example of what's called an isosceles triangle, which is a triangle where 2 sides have the same length. If we compare the lengths of this triangle's 3 sides, you can see it's isosceles because these 2 sides have equal length. The third side, over here, happens to be shorter than the other 2. Now take a look at these triangles. Which 2 of these are isosceles? Exactly, these 2 triangles are isosceles. Next, let's take a closer look at this other triangle. It's a scalene triangle, meaning all 3 of its sides have different lengths. If we compare the lengths of the sides, you can see that they all really do have different lengths. So take a look at these 4 triangles down here. Which 2 of these are scalene? Now it's time for you to make your own triangles. In this interactive triangle, you can move around the 3 corners, also known as vertices, by dragging the 3 yellow circles. Try making a triangle that's isosceles but not equilateral, so it should have exactly 2 sides with the same length. When you're ready, press the Submit button over here. Great work! Finally, try making an equilateral triangle. Once you've got one, press the Submit button. Let's see what happens when you add up the 3 angles in a triangle. Here's a sample triangle, and let's color its 3 angles. Now this angle over here is 51 degrees, this one is 62 degrees, and this one is 67 degrees. So what's the sum of these 3 angles? In other words, what's 51 degrees plus 62 degrees plus 67 degrees? And if you'd like to review what angles are instead, then click over here. Right. The angles in this triangle add up to 180 degrees. Now here's an interactive version of the triangle where you can drag around the 3 corners and make any triangle you want. The 3 angles are also shown over here, and at the moment they add up to an angle that forms a straight line. In other words, the measures of the 3 angles add up to 180 degrees. Try making a triangle whose angles add up to something other than 180 degrees. Seems like the angles of every triangle add up to 180 degrees. Let's see if we can prove this is true using this triangle here, whose angles have measures that we'll call A, B, and C. As a first step, pick any of the 3 corners of this triangle. Okay, you picked this corner over here. Here's the line that goes through the opposite side of the triangle, and let's make a parallel copy of this line that goes through this corner of the triangle that you picked. So these 2 lines, over here and over here, are parallel. Now let's look at this yellow angle over here. Which angle inside the triangle forms an alternate interior pair with this one? Is it angle A, angle B, or angle C? And click over here if you'd like to review alternate interior angles. Exactly! Because these 2 lines are parallel, this angle here has the same measure as this one over here, because they're alternate interior angles. So this angle has measure B as well. Now which angle inside the triangle is alternate interior from this one? Right, this angle has the same measure as this one over here, because they're another pair of alternate interior angles. So this angle also has measure A. Now notice that these 3 angles add up to a straight angle. So what's A plus B plus C? Exactly. The sum of these angles is 180 degrees. And this is true for any triangle. The three angles in every triangle always add up to 180 degrees. Now that you've proven that the angles in every triangle add up to 180 degrees, here's one last chance to try to find a counterexample. Maybe there's some triangle out there whose angles add up to something other than 180 degrees. Okay, next question. Here's a triangle, and let's say this angle is 30 degrees, and this angle over here is 90 degrees. Using the fact that the angles in every triangle add up to 180 degrees, find the measure of this blue angle up here. Nicely done! The three angles in this triangle must add up to 180 degrees, which means this angle has to be 60 degrees. So for your final challenge, suppose I tell you that the three angles in a triangle have measures of x, 3x, and 5x. Try using this information to solve for the variable x. If you get stuck, click down here. Before we get into right, obtuse, and acute triangles, do you remember what the angles in every triangle always add up to? If not, click down here to review. Exactly, the three angles in every triangle always add up to 180 degrees. Now recall that 90-degree angles, like this one here, are also known as right angles, and right angles are often labeled with tiny squares to show that they're exactly 90 degrees. Any triangle with a right angle is also known as a right triangle. So take a look at these triangles down here. Two of them have right or 90-degree angles. So which two of these are right triangles? Well done! So these two triangles over here are right triangles. This angle over here is a right angle, and this angle down here is another right angle. Now any triangle with an obtuse angle is also known as an obtuse triangle. Remember, an obtuse angle is any angle greater than 90 degrees but less than 180 degrees. So of these four triangles down here, which two are obtuse triangles? And to review obtuse angles, you can click over here. Nicely done. These two triangles are obtuse, and here's the obtuse angle in this triangle, and here's the obtuse angle in this triangle. Finally, if a triangle has three acute angles, meaning it doesn't have any right or obtuse angles, then it's called an acute triangle. Remember that an angle is acute if it's less than 90 degrees. So of these four triangles down here, which two are acute? Okay, now it's time for you to make your own right, obtuse, and acute triangles. First, try dragging around the three corners, or vertices, of this interactive triangle and make a right triangle. Once you've got one, press the Submit button over here. Great, so here's another example of a right triangle which has exactly one right angle over here. What's the greatest number of right angles a triangle can have? Precisely, a triangle can have at most one right angle, because if it has two, those two angles would add up to 180 degrees, leaving 0 degrees for the third angle. Similarly, a triangle can have at most one obtuse angle. Speaking of obtuse angles, next, try making an obtuse triangle. Nicely done. Here's another example of an obtuse triangle, which has an obtuse angle over here. Finally, try making an acute triangle, which is a triangle whose angles are all acute, or less than 90 degrees.